Hello students, welcome back to your computer networks lab session, and today we will be discussing about your experiment number 4, which is again based on network simulator. So last lab in experiment number 3 you have studied about wired LAN. So in experiment number 4 you will be studying about wireless LAN. So let's look into the problem statement. So the problem statements tell to implement a simple ESS with transmitting node in a wireless LAN by simulation and to determine the performance with respect to transmission of packets. Now let us first understand to each of these terminologies. What is a wireless network? What is a wireless LAN? What is ESS? And what is the performance that we are expected to track about? And what are the changes that you should do programmatically when we are constructing a simulation for a wireless network? So, firstly, talking about what is a wireless network. I think we are all very well used to the technology. I think all of us are dependent on Wi-Fi today, and we very well know what is a wireless network. A computer network that does not use any cabling technology, or which is not to get connected in a network. We are not using any cabling, but we are using some radio waves or frequencies that allows to be connected in a network coverage area. I stress upon the word coverage area because once you are out of the coverage, especially in the wireless network, there is a possibility you are no more a part of that network. Once you are out of the coverage area, you have lost the network and you have lost the connectivity also. So that is what you will be demonstrating and you will be checking for in your experiment number 4. So this is just a small illustration that I got. So you will have an access point or an antenna, and there could be various devices that could be connected to this wireless network. Now all these devices that is shown is connected to one common network, but all these are the nodes of the network, but none of it is cably attached. We have the types of network in wireless as well. We have wireless LANs, wireless MANs, and wireless WANs. So LANs, as you know, the feasibility or the range it could go, it is to a set of devices. A couple of LANs, or I can tell a group of or islands of LANs could be connected over a metropolitan area would be your wireless MAN. A larger coverage of area or a group of LANs together would make your WAN. I think you're already very clear about what is the feasibility or what is the area to which LAN, MAN, and WAN can expand. The same thing applies here, but for a wireless, the amount of uh, area is not same as that of your wired network. Now, very specifically to getting down to your question, here today we will be discussing about or we will be working on your wireless LAN. So wireless LAN again is a computer network that uses a high frequency radio wave to connect over a LAN network. It could be on a single floor, or it could be an office or a home connectivity we can look for. And this is based on your IEEE 802.11. IEEE 802.3 is for wired. IEEE 802.11 is a standard for your wireless LAN or the Wi-Fi network. So as I told, it is limited for a LAN network. So it could be for a single floor or a home or a small area to which it could connect. Now, what are the components that make up your wireless LAN? So, there are a set of components that is prescribed in the standard. We have stations, we have basic service set, extended service set. So, this was the ESS that we had in the question, and then we had the distributed system. So, what is a station? A station is a set of devices, equipments that is connected over a wireless LAN. Each station has a wireless network interface controller. So, station, it deals with an interface controller. Again, there are two types in that: wireless access point and client. What we commonly use is the wireless access point, that is the WAP, or it is also called as AP. If you open to your mobile, and you can see that in your mobile settings as well. The next thing that we have is about the basic service set. A basic service set is a group of stations that is communicating at the physical level layer. What is an extended service set? A group of basic service set would be your extended service set. Again, in your NAM file, I will show you what is a basic service set and what is an extended service set. So when we have a group of nodes, even if I have two nodes, if there is an exchange that is happening between the two nodes, if I call that to be a basic service set, if I have multiple nodes like that, that becomes an extended service set. I just have an image after this slide. So what is a distribution system? It connects all these ESS together. So you can see the topology here, how it is, or you can see the structure, how it goes. So we have the stations. The stations are called as a group of these, or a set of these are called as your BSS. And a set of these BSS, you can see 3 BSS here with the access point, that is the station's access point. AP is the access point, and the set of these BSS are called as extended service set. And the distribution system connects all these access points. The same thing what we discussed is illustrated here in the image. The next thing that we have, it is just a little information that you have to know. We will use one of this in the programming as well. So again, to have a subdivision, so we started with what is a wireless network. In wireless network, we had three types: wireless LAN, wireless MAN, and wireless WAN. And again, in wireless LAN, you have two modes in which it operates. One is the infrastructure mode, and the other one is the ad hoc mode. So what is an infrastructure mode? A device or a client gets connected to an access point, that is via a bridge or an internet the client transmits the frames to another client via the access point only. And on the counterpart, we have the ad hoc mode where the client transmits the frames directly to each other in a peer fashion. So in your lab program, what we use is the ad hoc mode. The next thing that we have is about some of the programming requirements. So what are the settings and configurations that we newly have when we have to simulate on the wireless network? So these are a set of parameters that we will have to configure when we start the program for network simulator. So let us see what are the parameters and what is the possible options that we have. Before we create any node, the node will contain these following components or parameters. So we have to decide the channel. A channel is a class, and in that we will take the channel type to be a wireless channel. And what is the mode of radio propagation? It is the two array ground. And then when we were discussing, we saw to that antenna. How are these nodes getting connected? It is via the antenna, and here there are various antenna types, and the most popular one that is used is the OMI antenna. And again, the data link layer is divided into two layers. One is the link layer type, and the other one is the other layer we have is the MAC layer. And you can also notice here the MAC layer we are choosing 802.11, that is the standard IEEE for the wireless or the Wi-Fi connectivity. And then we have the interface queue type. So the interface queue type is the priority queue. So the priority queue comes under your drop tail, and drop tail comes under the queue class. So what is the maximum queue size? So the maximum queue size here we are specifying it to be 50. And again, what is the network interface type? The network interface type is again wireless. The next one that we have is about the routing option or the routing protocol that is used. So here when we have a set of nodes that in the network, we shall decide what could be the easiest or the earliest path to reach a node. So here we have the DSDV routing protocol. So this is destination sequenced distance vector protocol. And lastly, we have the number of nodes. Here for the sample, we have specified it to be 2. I again repeat, these are the set of parameters. Along with it, you also have the trace parameters. So you can choose to on and off some of the traces. I'll show you that when we see the program. So we need to configure all these parameters, and then we will be able to create. The next thing that we have the basic setup, all these things that we were doing, your stimulator instance, the creation of your stimulator instance and the trace file. The two new add-ons to this is your topography and GOD object. Now, what is a topography? A topography is an object that is set to define a topology. Here, the topology we are talking about the coverage area. So, we have the coverage area, we are fixing up that to be a grid of 500 cross 500. So, if there is anything, if the node goes out of this coverage area, then probably it would have lost the connection. And the other and the most important thing that we have is about your GOD object. So, what is GOD? It is General Operations Directory. Now, let us see the purpose of your GOD. So, basically, this is also an object that is used to store the global information such as the status, the environment, the network, the number of nodes that it is having. So, for example, if I tell every time it keeps tracking about the total number of nodes. Now, as I told you, if there are some nodes that have traveled out of the network, so the number of nodes in the network reduces. So GOD is an object that is tracking these information. It also have the ability to have a short table which gives you the number of hops or the routing hops that is required to reach from one node to another also can be specified in this GOD object. So basically a GOD object acts like a tracker that is going to track the environment information, that is what is the network and how many nodes are there and which node is how far. All this information would be a part of your GOD. So I was talking about this is the configuration of the mobile node. So these are the parameters that we look to. So the link layer type, the MAC type, the interface queue, and all this what you have defined earlier, you are configuring it here. But the last three is what we have not discussed about: the trace agent and the router trace and the MAC trace. The trace file of a network simulator is not very similar to your other trace files that we have seen for the first three experiments. Here the trace file would vary. It is not a fixed 12 column format. So the trace file changes based on the on and off that you specify in the configuration. So if you wish to trace the agent, you can on that. If you wish to trace the router, you could be owning that. If you want to only look for the connecting agent, you can only trace that. So based on the options that you select, your eventually the trace file, the parameters in the trace file would also change. The next thing that we have is to create a node. So we could be giving a for loop when you have to create multiple nodes. That is, if you want to create a 50 or 100 node, so we could be doing that using this for loop. So you can give it at which point it has to, for how many nodes it has to stop. So this is also one of the possibilities that we have in a wireless simulation. The next thing that we have is about the moment specification. So you specify the wireless nodes are meant to be mobile. It is not like a stagnant of it is not stagnant like your wired connection. So in a wired network the node does not move, whereas in a wireless network the nodes are meant to move or mobilize. So here you can specify the movements. Here we are setting up the graph. We have the x, y and z axis. Z axis is usually a 0 because we tend to demonstrate a two-dimensional movement or a two-dimensional graphical representation. So z axis is usually a 0, and y and x axis you define how far or how further each node wants to move. So in the demonstration you can see here there are two nodes 0 and 1, and your setting and how, in which direction, how far it has to move in an x direction and how far it has to move in a y direction. So as I told you, there are chances that the nodes go out of the network, the nodes go far off each other. So that is where we have to specify the moment specification in case of wireless simulation. The next thing is about the connection setup. This is as usual, as we have done it previously to the other experiments. So you fix up with the connection type and you attach a connection agent, and then you create the source, you attach the node to the agent. So let us see what is the expected output, and then we will have a quick walkthrough to the program. Now, what does the program tell? We have to create a simple ESS, and there should be some transmission that happen between the nodes, and then we are supposed to track the performance. So we can see here we have created 3 nodes. You can see a small circle here and there are 2 nodes. This one group will be one BSS, and when there is a movement, when one of these node is acting as a sender and the other one to be the receiver, that both together becomes another BSS, and a couple of these BSS is one ESS on the whole. Now, what is expected output here, or what is that you can see here is, now I have set a grid of 500 cross 500 to be the coverage of my network. And you can see here there are 2 nodes that is closer and there is one node that is far. So when I just start moving away from the node that is close, during my transmission, now there is a data transmission that I am performing, and over the transmission, when the node starts getting away, you can evidently see that there is a packet drop. So it is not able to successfully deliver it to the receiver. So what is that we are demonstrating here? It is something quite evident that you're seeing in your that you have all used in your day-to-day life. Now, for example, for some of the transfers that you do from your cell phone to your friend's cell phone, you use various apps. I think ShareIt was popularly there before, and then ShareMe came, and now we have Google Files. There is a distance or there is a range in which this transmission can happen, and if the two connecting devices are very far, or during the transmission, for example, you have started transferring some 200 photos, and during the transmission, if one of the devices have moved far off, what happens, the connectivity breaks and the transmission is not successful. After some 100 photos it stops. So the same thing happens here. So after a certain point where it is not able to reach, the packet starts dropping. So here we track the performance. So we are tracking the performance here based on the throughput. Now, what is a throughput? So it tells you the number of packets that is transferred between 2 nodes at a given instance of time, how much of that we could transfer. And again, this is extracted from the awk file or your awk file using the trace file of your simulation. So this is the expected output that we have. I think we have seen through the information what is required to know about the wireless network simulator. Now let us have a quick walkthrough to your program. Now let us have a quick walkthrough to your code. So we have already seen the problem statement. It is to implement a simple ESS with the transmitting node so that each node is capable of sending or receiving the data, and we will have to calculate or determine the performance. So here we are determining the performance using the throughput. So as I told you, the nodes will be involved in the transmission and the nodes also mobilize. So there are chances when the nodes go away a lot, the packet starts dropping. So when the packets have dropped, the performance is also low, the throughput is also low. So the number of packets that is transferred at a given instance of time it would eventually be low. So as discussed, we create your simulator object, and the new object that we are creating here is the top, that is the topography or the topology, and here we are taking the grid to be 1000 cross 1000. And the next thing that we have is about the configuration. So we have seen to all these parameters. Now we are configuring all these parameters to the net simulator object ns. So we are configuring it. We have the link layer type, the MAC, the interface queue, the length, the interface type, the channel, and to the last we are only tracing the we are only tracing the network agent and the router trace. So we are only tracing these two and we are enabling those two trace, and we are also creating the GOD. We have already discussed what is the purpose of GOD. And then we are creating three nodes, that is node 0, node 1 and node 2. And here we are labeling the nodes so that you can identify which is a sender, which is a receiver. Here we have node 0, which is going to act only as a sender. We have the node 1, which is capable of acting as a sender as well as the receiver. We have the node 2, which is going to act only as a receiver. I repeat, we have three nodes, node 0, node 1, node 2. Node 0 acts as a sender, node 2 acts as a receiver, node 1 is capable of sending as well as receiving. So we have told about the movement specification. So here you are setting the initial point. So we have the grid of 1000 cross 1000. In that 1000 cross 1000, where are you placing the node 0, node 1 and node 2 initially? You can see here the z-axis is all 0. So node 0, I am fixing it up at 50 cross 50, or at the point 50, at the intersection of 50 50. And node 1, I am fixing it up the intersection of 100 100, and node 2 at 600 600. So at the very first time interval 0.1, these nodes would be placed, or it starts there, and then you have then we can have movements where we will talk about the movements, I mean which direction it has to move. The next thing that we have is about the connection agent. So here we are creating the connection agents, and we are attaching the connection agents with the nodes. We have already had a deep discussion of the connection agents in the last three programs. And here to start the procedure, to start the NAM file, and it is to finish at what a point is what is given. Now the purpose of the awk file. So here we have two BSS, or we have the two sets. So here also we are tracking the throughput of two nodes. So that is why we have count 1, count 2, packet 1, packet 2, timer 1 and timer 2. So you can see here throughput from node 0 to node 1, again throughput from node 1 to node 2. So to calculate the throughput, I need at the given instance of time the number of packets that is transferred. So I will be extracting that in this if loops. So the time instance, the number of packets, and the count will be extracted. Here we have $1, which is telling it to be R. R is the packet received. And then we have $3, that is 1, that is nothing but the first connection, that is node 0 to node 1. And then we are tracing the agent trace is the AGT, and then we are incrementing the counter, and then the packet is equal to packet plus $8. $8 is the complete, the number of packets that is transferred, the complete information is stored and at the time instance. So we are calculating the same thing for the other connection, N1 to N2, and then finally we calculate the throughput. So I have already given the description about the output, that is the NAM file, where you have the 3 nodes. We have the node 0 and the node 1 in this circle, and the node 2 is here. So as the node move away, you can notice the packet drop, and we also have the throughput. So this is about your experiment number 4. Thank you, students.